So I'm back today for another lesson on exponent rules and how to use exponent rules in terms of simplifying expressions. So check out what we have here. We have a division problem where we have two fractions, right? I know it doesn't look like a simple division problem with two fractions, but that's basically what it is. Even though it's got a lot of variables, a lot of different variables with a lot of different exponents. We got positive exponents, we got a negative exponent. It's just a lot going on, right? But we're going to approach this the same way we would approach just dividing two fractions. All right. So the first thing I'm going to do is I'm going to implement the keep, change, flip procedure, right? So I'm going to keep this fraction the same way, right? Meaning I'm going to rewrite the entire problem, but I'm going to keep this fraction the same. I'm going to change this division sign to a multiplication sign, and I'm going to flip this fraction. And when I say flip, more technically, I mean I'm going to take the reciprocal of it, right? When I rewrite the expression. Or another way to think of that is the numerator and the denominator are going to switch places. So the numerator is going to go down here and become the denominator. This denominator, 2n, is going to go up top and become the numerator. So this is what it's going to look like. This stays the same, right? Because I'm going to keep that. So it's going to be 2r to the negative 5y to the third over n squared. All right, so we kept that. That stayed the same. This division sign, it changes. That changes to a multiplication sign. I'm going to use the dot for multiplication. All right. We flip the second fraction, meaning we take the reciprocal of the second fraction. So this denominator 2n is going to become the numerator. This numerator, r squared y to the fifth, is going to become the denominator. So it's going to look like this. 2n over r squared y to the fifth. Now that's my first step. Now I look for different things I can simplify. I look for similar variables. I look for variables that are the same, right? And I start thinking about like, okay, can I use the multiplication rule? Can I use the division rule? Can I use the negative exponent rule? Like, I just got to look and see what I could do. So for one thing, I see an n squared right here, and I see an n over here, right? This n is in the numerator over here. This n squared is in the denominator over here. Even though these two variables are in different fractions, we can treat them like they're in the same fraction, because if I did multiply across, I could combine these, right? I could combine them. So then it would be just one big happy fraction, right? All together. Matter of fact, I'm gonna show you what that looks like. So I can think of it as 2r to the negative 5, y to the third, times 2n over n squared times r squared y to the fifth. You see, I could just combine these into one fraction. So now, since they're in one fraction, now when I think about the division rule, I can say, all right, well, this n, I'm gonna switch the color up real fast. This n and this n, I can use the division rule for those. All right, and then this y and this y, I can use the division rule for those. And then, let's see if I got another color. I got green. Cool. This r right here and this r right here, I can use the division rule for those. Right? That's what I can do. So, and then this 2 and this 2, that's just straight 2 times 2. And 2 times 2 is 4. So I'm going to bring it back over here. I'm going to do 2 times 2. That's going to give me 4. Right? And now I'm going to deal with the variables one at a time. I'm going to try to be systematic and stay organized and be real orderly. Right? So I don't lose track of what I'm doing. I'm going to deal with the r's first, only because r is the first variable I see after the 2. So I got r to the negative 5 on top. I got r squared on the bottom. The division rule says that you subtract the top exponent minus the bottom exponent, meaning we would do negative 5 minus 2. Negative 5 minus 2. Negative 5 minus 2, we're going deeper into the negatives. That's going to give me negative 7. So I'm going to have r to the negative 7. Now I'm gonna have to do something with that because we can't end up with a negative exponent. We got some more simplifying to do, but we're gonna get to that in a minute. So I just dealt with the r's. Now I'm gonna deal with the y's. I got y to the third and y to the fifth. Division rule again. 3 minus 5, -2. Now notice how after we use the division rule, our variable, we think of it as being left in the numerator, not in the denominator. So think of this as the numerator. So I got y to the -2. Then I deal with the n. Excuse me. I got n divided by n squared. So n doesn't have an exponent written. But whenever there's no exponent written, we know that the exponent is a +1. Always remember that. If you don't see an exponent written, just know it's a +1. So that's +1 minus 2. 1 minus 2 is -1. So now we got n to the -1. And there's nothing else left in the denominator because the n squared is dealt with, the r squared and the y to the fifth. We used the negative exponent rule. I'm sorry, we didn't use that. We used the division rule, the division rule. We're about to use the negative exponent rule because watch this. You see how you got all these terms. So, but they have negative exponents. The r does, the y does, and the n does. So we're going to make this look like a fraction, right? We make it look like a fraction because in order to use the negative exponent rule, what we got to end up doing is taking the reciprocal of everything that has a negative exponent. Not the 4. The 4 has an exponent of +1 because no exponent is written. The r has a negative exponent. The y has a negative exponent. The n has a negative exponent. So all of these are going to basically go down. The r is going to go down. The y is going to go down. And the n is going to go down. The only thing that's going to be left in the numerator is that +4. So 4 is your numerator. And then when the r goes down, its exponent, which was -7, turns into a +7. So we end up with r to the 7th. When the y goes down, that becomes y to the 2nd. When the n goes down, that becomes n to the 1st. And the n to the 1st, I don't need to write the exponent when the exponent is a +1. We don't need to write that. All right. As a matter of fact, in simplest form, you should not write the +1 when it's your exponent. Okay. Now, if you're wondering what happened to this 1 is still there. Just think of it as the invisible coefficient. Invisible coefficient. Think of it as that. I'm gonna write that up there because I like that. Invisible coefficient. I'm gonna have to start using that term more often. So think of this 1 as the invisible coefficient, which would be in front of this r to the 7th y squared n. So this right here is your final answer. Let me draw a box around this. So just keep in mind what we did. We started out with a division problem with 2 fractions. We followed our keep, change, flip procedure, which we always do whenever we're dealing with the division of 2 fractions. Nothing changes. Just because we got a bunch of variables and we got a negative exponent, nothing changes. We still did that. We combined the 2 fractions through multiplication, right? And then we used the division rule with the variables that were the same on the top and the bottom, all right? And then we used the negative exponent rule. So the key to these problems is just being able to recognize what's going on in the problem and knowing when and where to use each rule, right? Now, we could have went in a different order. There's no real, usually one set way that we have to use the rules. Like I chose to use the division rule first and then use the negative exponent rule. But what I could have did was I could have used the negative exponent rule from the beginning with this r to the -5. And I could have moved that down to the denominator as a first step or as an earlier step. But I just chose not to do that. But I wanted to point that out because I want to show you that you do have options when you're dealing with the exponent rules. So the exponent rules are very important, and keep practicing these types of problems and you'll master them. There are about 5 exponent rules that you need to know. So whenever you see them, you'll be able to, whenever you see a problem like this, you'll be able to complete problems like this dealing with the exponent rule. All right. So again, if you haven't subscribed to the channel, please hit that button, subscribe to the channel, like the video, share this video, send it out to somebody, send it out to a bunch of people. Let people know what we're doing over here, All This Math. And as usual, as I always say, do remember, there's all this math all around you. Peace.